December 7th, 1941, Pearl Harbor. Commander Mitsuo Fuchida circled above the devastation his strike force had unleashed, surveying the broken battleships and burning fuel depots below. Through the smoke and flames, he transmitted the code that would echo through history. Tora, Tora, Tora. The surprise was complete. The American Pacific Fleet lay crippled. Victory seemed assured. What Fuchida could not see from his cockpit that morning, what no Japanese military planner had fully comprehended, despite years of intelligence gathering, was that they had just awakened an industrial giant whose productive capacity would prove more devastating than any weapon in their arsenal. The attack on Pearl Harbor did not begin the Pacific War's decisive battle. It began an industrial race that Japan had already lost before the first bomb fell. The mathematics were brutal and inescapable. In 1941, the United States possessed 17 times Japan's national income and 5 times its steel production. America's gross national product exceeded Japan's by a factor that made defeat not just probable, but mathematically inevitable. Yet Japanese military planners, intoxicated by their victories in China and convinced of American weakness, chose to ignore these numbers. They calculated that American resolve would crack, that a negotiated peace would come before industrial might could be fully mobilized. They were catastrophically wrong. The shipbuilding disparity revealed this miscalculation in its starkest form. On the morning of December 7, 1941, Japan possessed one of the world's most formidable naval forces. The combined fleet included 10 aircraft carriers, the largest carrier force in the world. Their merchant marine numbered over 6 million tons of shipping, ranking third globally behind only Britain and the United States. Japanese shipyards were among the finest in the world, having built vessels that combined advanced engineering with exceptional craftsmanship. The massive dry dock at Kure Naval Yard, completed in 1912, could accommodate ships of unprecedented size. It was in this very dock that workers would later construct the Yamato, the largest battleship ever built, displacing 69,100 tons and mounting guns no other nation could match. But size and quality meant nothing against the tidal wave of American production that was about to be unleashed. The pre-war Japanese merchant fleet of 6.4 million tons seemed impressive until compared to American shipbuilding capacity. Japan estimated it needed approximately 5.9 million tons of shipping to maintain its economy and military during a major war. This calculation, made by their naval general staff, was based on World War I shipping loss rates. They predicted annual losses of 800,000 to 1.1 million gross tons in the first year, declining slightly in subsequent years. These estimates would prove so wildly optimistic as to border on fantasy. The reality of Japanese shipbuilding capacity became apparent as soon as the war began. Japanese shipyards were concentrated in a handful of major facilities: Kure Naval Yard with its 300-meter ways, Yokosuka Naval Yard, Sasebo Naval Yard, and Maizuru. Naval Yard formed the backbone of naval construction. Private yards like Mitsubishi at Nagasaki, Kawasaki at Kobe, and others supplemented government facilities. But beginning in 1943, these yards became catastrophically overcrowded. New construction competed with damaged warships requiring immediate repair. The yards had to simultaneously build combat vessels, replace merchant shipping losses, and construct the escort vessels they had desperately neglected to produce before the war. The Japanese never developed a cost-effective destroyer escort suitable for convoy protection. Throughout the entire war, Japan managed to build just 63 destroyers, some 20 of which would have been classified by the Allies as destroyer escorts. This was an island empire totally dependent on maintaining open sea lanes to ensure raw material imports. Yet, in that same time span, the United States put 847 anti-submarine capable craft in the water. This figure doesn't even include the smaller sub-chasers and armed yachts used off America's eastern seaboard against German U-boats. The disparity in aircraft carrier production told an equally devastating story. Following the catastrophic losses at Coral Sea and Midway in mid-1942, the Japanese Imperial Navy frantically developed plans to replace their carrier losses. On June 30, 1942, they approved a program to build 14 Unryu-class fleet carriers. It was an ambitious plan born of desperation, but ambition meant nothing without industrial capacity to support it. Consider the construction timeline for just 3 carriers. The Japanese laid down the Unryu, Amagi, and Katsuragi and required 24, 22, and 22 months respectively to complete them. The United States, building Essex-class carriers that displaced 63% more tonnage than the Unryu-class, required only 16, 16, and 20 months for comparable vessels. American shipyards built twice as much carrier tonnage per day and delivered each ship 24% faster than their Japanese counterparts. The Unryu, Amagi, and Katsuragi were commissioned in the fall of 1944, far too late to affect the war's outcome. The Unryu sortied once on a logistics mission in December 1944 and was immediately torpedoed and sunk. The other two never saw combat. Meanwhile, American shipyards had created an armada that dominated the Pacific. By 1945, the U.S. Navy was larger than every other navy in the world combined. But the true revolution in American shipbuilding came not from warships, but from merchant vessels. The Liberty Ship program represented an industrial achievement that fundamentally changed how ships were built and, ultimately, determined who would win the war. These vessels, initially derided by President Franklin Roosevelt as dreadful-looking objects and nicknamed ugly ducklings, would prove to be among World War II's most decisive weapons. The Liberty Ship was born from desperation. By 1941, German U-boats were sinking Allied merchant vessels faster than traditional shipyards could replace them. Britain stood alone against Nazi Germany, its survival dependent on transatlantic supply lines that were being systematically severed. The solution came from an unexpected source: Henry J. Kaiser, a construction magnate with no traditional shipbuilding experience, but a revolutionary vision of how industrial mass production could be applied to shipbuilding. Kaiser had built his reputation constructing massive dams, the Hoover Dam, Bonneville Dam, and Grand Coulee Dam. He understood large-scale project management, efficient use of labor, and the principles of assembly line production. When he turned his attention to shipbuilding in 1940, he brought these lessons with him. Traditional shipbuilders were skeptical. Ships, they insisted, were complex vessels requiring skilled craftsmen and months of careful construction. Kaiser saw them differently, as large machines that could be assembled from standardized prefabricated components. The Maritime Commission's standardized Liberty ship design provided the perfect platform for Kaiser's methods. At 441 feet long and 56 feet wide, Liberty ships were deliberately simple. They operated at just 11 knots, slow but adequate. They could carry 10,800 deadweight tons of cargo, 2,840 jeeps, 440 tanks, or 230 million rounds of rifle ammunition. Built for just under $2 million each, they were designed not to last decades but to survive long enough to deliver their cargo. Kaiser's revolutionary approach centered on three key innovations. First, welding replaced riveting. Traditional ships were riveted together, a process requiring skilled workers and consuming enormous time. A single Liberty ship required approximately 3 million rivets if built traditionally. Welding was faster, lighter, and required less steel because plates didn't need to overlap. More critically, welders could be trained in little more than a week, while riveting required months of apprenticeship. Each Liberty ship ultimately required nearly 50 miles of welding. Second, prefabrication transformed ship construction. Rather than building ships sequentially from keel to completion, Kaiser's yards fabricated massive sections simultaneously at different locations. Entire deck houses, double-bottom sections, stern frame assemblies, and bow units were built separately, then moved into position with massive cranes and welded together. Each Liberty ship comprised approximately 250,000 individual parts, fabricated throughout the country in 250-ton sections. Workers who had never seen a ship became specialists in specific tasks, assembling components with precision that equaled or exceeded peacetime standards. Third, Kaiser applied true assembly line techniques to shipbuilding. His Richmond, California, Shipyards, 4 massive facilities covering 880 acres, became the largest shipbuilding center in the world. At peak capacity, these yards employed over 90,000 workers and operated 27 shipways running 3 shifts, 24 hours per day. The yards attracted workers from across the nation, including tens of thousands of women and African Americans who had been excluded from such industries before the war. By April 1943, apart from office workers, 40% of laborers in Kaiser's shipyards were women. The results defied belief. The first Liberty ship, SS Patrick Henry, launched in September 1941, required 244 days to build. By 1943, the median construction time had dropped to just 39 days. Kaiser's Richmond yards routinely completed Liberty ships in little more than 2 weeks. In November 1942, the SS Robert E. Peary was assembled in an astonishing 4 days, 15 hours, and 29 minutes as part of a competition between shipyards. While this was a publicity stunt requiring special preparation, it demonstrated the potential of American industrial methods. Between 1941 and 1945, American shipyards built 2,610 Liberty ships. 18 different yards participated in the program, but Kaiser's facilities dominated, producing 519 Liberty ships, almost a quarter of total U.S. production. At the war's peak, the United States delivered nearly 800,000 tons of shipping per month, approximately 70 times the average rate of merchant shipbuilding during the 1930s. For a brief period during the war, the United States was responsible for nearly 90% of worldwide shipbuilding. This flood of ships allowed the United States to overwhelm German submarines, literally building vessels faster than they could be sunk. In 1941 and 1942, German U-boats sank 2,963 Allied ships. American yards built 863 replacements in that same period, and that was before production reached full capacity. By 1944, the equation had reversed completely. American submarines and aircraft were sinking Japanese merchant ships faster than Japan's yards could replace them, applying the same strategy to Japan that Germany had attempted against Britain. The contrast with Japanese shipbuilding could not have been more stark. While the United States built nearly 9,000 war vessels during World War II, more than 3 times the amount of all other powers combined, Japan struggled to maintain even a fraction of that output. Japanese shipyards, despite their pre-war reputation for excellence, lacked the resources, raw materials, and systematic approach that characterized American production. Japan's shipbuilding capacity was constrained by fundamental limitations. Steel production, the foundation of any shipbuilding program, could not match American output. The United States produced 5 times more steel than Japan even before the war. As the conflict progressed and American submarines severed Japan's supply lines to resources in Southeast Asia, Japanese steel production collapsed. Nickel, chromium, molybdenum, and other alloying elements essential for high-quality steel became increasingly scarce. Japanese manufacturers were forced to substitute inferior materials, reducing the quality and reliability of everything from ship plates to aircraft engines. The shortage of skilled workers compounded these material constraints. Traditional Japanese shipbuilding relied on experienced craftsmen who had trained for years. As these workers were drafted into military service or shifted to other critical war industries, replacements lacked the expertise needed for complex vessel construction. Quality control deteriorated. Ships that would have taken months to build instead required years, and even then often suffered from construction defects. Most critically, Japan never adopted the systematic assembly line approach that made American shipbuilding so effective. Japanese shipyards continued building ships one at a time using traditional methods. There was no equivalent to Kaiser's prefabrication system, no nationwide network of suppliers producing standardized components. Each ship remained a largely custom build, requiring enormous investment of time and resources. The strategic implications of this disparity extended far beyond simple numbers. American merchant vessels formed the logistical backbone that sustained operations across the vast Pacific. Every island campaign, every offensive, every bombing raid depended on a continuous flow of supplies, transported in Liberty ships and their successor Victory ships. When Marines landed on distant atolls, Liberty ships delivered the ammunition, food, fuel, and equipment that sustained them. When B-29 superfortresses bombed Japan's industrial centers, Liberty ships had transported the bombs, aviation fuel, and spare parts that kept them flying. Japan, conversely, watched helplessly as its merchant fleet was systematically destroyed. On December 7, 1941, the Japanese merchant fleet stood at 6.4 million tons. By August 1945, less than a quarter of that tonnage remained operational. Of the 2,346 Japanese merchant ships destroyed during the war, 2,819 fell victim to U.S. Navy or Army Air Force action. American submarines alone accounted for 56% of Japan's merchant marine losses. U.S. Navy submarines sank approximately 1,213 merchant ships, totaling 4.8 million tons, along with 201 warships, including a battleship, 8 carriers, and 11 cruisers. Each sinking represented far more than tonnage lost. Merchant ships carried the oil that fueled Japan's fleet, the iron ore that supplied its foundries, the rubber that equipped its vehicles, the food that fed its population. As these supplies dried up, Japan's war machine ground to a halt. By 1944, Japanese aircraft sat grounded for lack of aviation fuel. Warships remained in port because there was no oil to operate them. Factories closed because raw materials could not reach them. Pilot training was curtailed because there was insufficient fuel for practice flights. Japan's failure to protect its merchant shipping stemmed from a fundamental misunderstanding of modern warfare. The Imperial Japanese Navy, focused obsessively on decisive fleet battles, accorded anti-submarine warfare a shockingly low priority. Few warships and aircraft were allocated to protecting merchant vessels. Japanese destroyers, impressive in night combat, had deficiencies in sonar and radar compared to Allied equivalents. More critically, Japan never developed adequate numbers of the small, economical escort vessels needed for convoy protection. It wasn't until October 1943, nearly 2 years into the war, that Japan began producing dedicated convoy escorts, the Kaibokan frigates. These 220-foot vessels, displacing 1,000 tons and equipped with depth charges and sonar, finally provided some protection for merchant convoys. By May 1944, 145 had been completed, but this was too little, too late. The damage to Japan's merchant fleet was beyond repair. Even Japan's attempts to replace carrier losses through conversion programs revealed the futility of their position. The Japanese converted 13 vessels to aircraft carriers during the war, including passenger liners, seaplane tenders, and even submarine tenders. The conversions were more successful than new construction, but most served as aircraft transports or convoy escorts rather than combat carriers. Of 7 auxiliary carriers created from passenger ships, only Junyo survived the war. The others were sunk by American submarines in 1943 and 1944, often while performing escort duties. The industrial disparity extended beyond ships to the infrastructure supporting them. American shipyards benefited from a continental industrial base with virtually unlimited resources. The Maritime Commission coordinated production nationwide, tracking construction progress, scheduling which ships would be built where, and ensuring materials arrived when needed. When shortages threatened, the Commission worked to expedite orders and secure scarce components. This systematic approach prevented bottlenecks and maintained production momentum. Japan had no equivalent coordination. Shipyards competed for limited steel allocations. Critical components like propeller shafts, boiler tubes, and electrical systems were perpetually in short supply. Damaged warships awaiting repair blocked construction ways needed for new vessels. The vicious cycle accelerated. Losses mounted, replacement capacity diminished, and strategic options narrowed. Perhaps the most telling statistic of the entire war came from the escort carrier program. The United States built 77 escort carriers of the Casablanca class alone in just 21 months. 50 of these vessels were commissioned in the single year between July 1943 and July 1944. Henry Kaiser's Vancouver, Washington shipyard achieved this while simultaneously producing Liberty ships and other vessels. The scale was unprecedented. 1 escort carrier and multiple merchant ships completed every few days from a single shipyard complex. Japan, despite its pre-war naval expertise and years of carrier operations experience, completed only 7 escort carriers during the entire war, most of them conversions rather than purpose-built vessels. The Japanese built no light or escort carriers from the keel up during the war. Every carrier commissioned after Pearl Harbor had been either laid down before hostilities began or converted from existing hulls. By 1945, the disparity had become absolute. The U.S. Navy operated 28 fleet carriers and 71 escort carriers. Japan had 4 carriers remaining, none of which could effectively operate due to lack of fuel, trained pilots, and aircraft. American factories were producing warships faster than Japan could sink them, even if Japan had possessed the aircraft and pilots to mount effective attacks. The industrial race was over. It had never really been a contest. In retrospect, Japanese military leaders should have recognized these facts before Pearl Harbor. Internal Imperial Navy studies conducted in 1941 had shown exactly these trends in naval shipbuilding. The United States possessed superior resources, superior productive capacity, and superior ability to sustain losses and continue fighting. Every metric predicted Japanese defeat in a prolonged war. Yet the Tojo government chose war anyway, driven by internal political dynamics that made peaceful disengagement from China politically impossible. Despite knowing that only abandoning China would lift the American economic embargo, the Japanese embarked on what can only be described as a suicidal venture against an overwhelmingly larger foe. Their greatest mistake wasn't merely disregarding American industrial strength. It was failing to understand that modern warfare had become fundamentally an industrial rather than a martial contest. The numbers tell the final story with brutal clarity. During World War II, the United States built 2,110 Liberty ships, 531 Victory ships, 17 Essex-class fleet carriers, 11 Independence-class light carriers, 77 Casablanca-class escort carriers, hundreds of destroyers, destroyer escorts, and other combat vessels, nearly 9,000 total war vessels Japan built, approximately 600 merchant ships during the entire war, 6 fleet carriers, including conversions, 4 light carriers, 7 escort carriers, 31 destroyers. The comparison reveals not just a disparity, but an impossible chasm. American shipyards were producing more tonnage in a single month than Japanese yards produced in a year. This wasn't merely a matter of working harder or longer hours. It represented a fundamental difference in industrial philosophy and capability. American mass production techniques, standardization, prefabrication, assembly line methods, systematic coordination, created a multiplication effect that traditional craftsmanship could never match. A single Kaiser shipyard with newly trained workers could outproduce Japan's finest naval arsenal staffed by master shipwrights. This wasn't because American workers were more skilled. It was because American industry had systematized construction in ways that made individual skill less critical than efficient organization. The legacy of this industrial race extended far beyond World War II. The techniques pioneered in Liberty ship construction, welding, prefabrication, modular assembly, became standard practice in post-war shipbuilding worldwide. Japan's post-war shipbuilding industry, rebuilt from the ruins, would eventually become the world's largest by adopting these same American mass production methods combined with their traditional attention to quality. The lesson was clear. In modern warfare, industrial capacity matters more than martial valor. Japan's sailors fought with exceptional courage and skill. Their warships were often superior in design and capability to American equivalents. Individual Japanese shipyards produced vessels of exceptional quality, but none of this mattered against an opponent who could build 10 ships for every one Japan produced. The Pacific War was decided not at Midway or Guadalcanal or the Philippine Sea, though these battles shaped the war's course. It was decided in the shipyards of Richmond, California, and Wilmington, North Carolina, and dozens of other American ports where workers, many of whom had never seen an ocean before Pearl Harbor, assembled vessels with systematic efficiency that overwhelmed any opposition. Japanese pilots who survived the war would later speak of their realization that defeat was inevitable. It came not from losing battles, but from seeing American ships arrive in ever-increasing numbers. Every convoy brought more vessels than the previous one. Every engagement, even if tactically successful, faced larger American forces than before. The Americans could afford their losses. Japan could not. Commander Fuchida, circling above Pearl Harbor in December 1941, could not have imagined this outcome. He saw American battleships burning and considered the raid a historic success. What he could not see, what no one in the Japanese military fully grasped, was that those battleships were already obsolete, that carriers would dominate naval warfare, and that American shipyards would produce carriers by the dozen, while Japan struggled to replace each loss. The industrial race between Japanese and American shipyards was over before it began. Japan entered the war with excellent ships and experienced builders. America possessed something far more powerful, an industrial system capable of translating raw resources into finished vessels at a pace the world had never seen. In the end, quality bowed before quantity. Craftsmanship yielded to systematization, and the nation that could build ships fastest won the war. The mathematics were always brutal and inescapable. Japan just chose to ignore them until it was far too late. If you found this deep dive into World War II's industrial warfare fascinating, make sure to like this video and subscribe to our channel for more detailed explorations of history's pivotal moments. What aspect of the Pacific War should we examine next? Let us know in the comments below. Thanks for watching, and we'll see you in the next one.